In this set of notes, we're going to be learning how to factor when our leading coefficient is 1 for a trinomial. The first thing I want to talk about is factor sets. You're going to find all the factor sets for the given number and then decide what pair adds up to the target number. So the factor sets of 4 are numbers that multiply to 4. So I have 1 and 4. That's a set. I have a set of 2 and 2. And I also could make each of those negatives. So I could have a set of -1 and -4, as well as a set of -2 and -2. The pair that adds up to 5 would be the 1 and the 4. So that's the pair I would want to keep. Factor sets of -6 are -1 and 6. I can switch those around and do +1 and -6. Or -2, +3. Switching those around, I could have +2 and -3. And the set that adds up to 1 is the -2 and 3. For the factor sets of 12, they can either both be positive or both be negative. So I have 1 and 12, -1, -12, 2 and 6, -2, -6, and then 3 and 4, -3 and -4. So that's everything that multiplies to +12. And the pair that adds to -7 would be the -3 and -4. Our next factor set is going to be huge. I think I'll start up here so I have a couple lines. So we have 1 and -36. We have -1 and +36. I also have 2 and -18. -2, +18. My next pair will be 3 and -12. I also have -3 and +12. Then 4, -9, -4, +9. And then the last one I have is 6 and -6. Notice -6 and +6, that's the same pair because we're not worried about the order. This is just a set. So I've used set notation for all of this. And which set adds to -5 would be the 4 and the -9. We're going to look and talk about products and sums next. And then we're going to put this together in order to factor. So I want two numbers that multiply, that have a product of 7. So they multiply to 7, and they have a sum of 8. Another word for sum is add, so they add to 8. So if they multiply to 7, they're either both positive or both negative. Since they add to a positive, both numbers will have to be positive. So I'm just going to list the numbers that multiply to 7. So that is 1 and 7. And notice those do add to 8. So here is my pair that I want. For number 6, I want them to have a product of -8. So that means that they're going to multiply to -8. And then they have to have a sum. They have to add to 2. So the numbers that multiply to negative 8, that means that one of them has to be positive, one of them has to be negative in order to multiply to negative 8. So you have 1 and 8. One of them needs to be negative. We'll make the first one negative. I can switch that around. I can have 1 and negative 8. Other numbers that multiply to negative 8 would be 2 and negative 4, negative 2, and positive 4, and there aren't any others. So let's look at the pair that adds to 2, and only one of those will add to 2. It's going to be this pair right here. On number 7, we want it to have a product of 8, so it needs to multiply to 8. And I want it to have a sum, or I want it to add, so you can use whichever word you want. So sum or add to negative 6. Okay, since it multiplies to a positive number, both numbers are positive or both numbers have to be negative. Since they add to a negative, we know that both of the numbers are going to have to be negative. So we can write our possible numbers, 1 and negative 8. Unfortunately, those don't add to negative 6. Our only other pair is negative 2 and negative 4, and that pair does add to negative 6, so there's the one we want. On number 8, we want it to have a product of 9, so it needs to multiply to 9, and it needs to have a sum of negative 6, so it needs to add to negative 6. So let's look at the numbers that would do that. They have to multiply to a positive, but add to a negative. So they're either both positive or both negative if they multiply to a positive. Since they're going to add to a negative, that means both numbers have to be negative. So I have negative 1, negative 9. 2 doesn't go into 9. 3 does, so this is going to be negative 3, negative 3. And there's no numbers between 3 and 3, so there are no other numbers that will go into it. 4 or 5, those won't go into 9. So we've listed everything that multiplies to 9 and would add to a negative, and the one that adds to the negative 6 is the negative 3, negative 3. We're going to put this together now. We're going to be factoring something in the form x squared plus bx plus c. And these are not going to have the greatest common factor right now. We're going to find our product c. So that's your last number. So it does not have an x in it, so it does not have a variable. This is just your constant. So it needs to multiply to the constant. And the numbers that will do that, if c is positive, your two numbers are going to have the same sign. So they're either both positive or both negative, because a negative times a negative is positive, and a positive times a positive is positive. If your constant is negative, they're going to have different signs or opposite signs. So one is going to have to be positive, one is going to have to be negative. So you're going to find your factor sets for your product and find the one that has a sum of b. You'll look for the factor sets first, then look for which one has the correct sum. So we did that in the last two pieces of the notes. We're going to identify the set that works for both the product and the sum. This is what m and n are in the next step. So whatever numbers work, you're going to fill in for your m and your n. So on this one, let's look at the first one on number 9. It has to multiply to the constant, so it's going to multiply to 4. And it needs to add or have a sum of 5. Since it multiplies to a positive, they're either both positive or both negative. It's adding to a positive, so that means that both signs have to be positive. So the numbers that multiply to 4, we have 1 and 4, and 2 and 2. And my pair that adds to 5 is this first one. And I'm going to plug those in now, those numbers in for m and n. So this will be x plus 1 times x plus 4. You could have written the x plus 4 first and the x plus 1 second, because there is no difference when you switch around in multiplication. If I had two numbers, 2 and 3, 2 times 3 is the same thing as 3 times 2. So it doesn't matter which order you put each of the factors in. For number 10, it has to have a product or multiply to the constant. So it has to multiply to 12. And it needs to have a sum or add to negative 7. Since it's multiplying to 12, either both positive or both negative, and since they're going to add to a negative, we know they both have to be negative. So we have negative 1 and negative 12. We have negative 2 and negative 6 and negative 3 and negative 4. And here is the pair that works. And so I fill that in for m and n. So this is going to be x plus negative 3, which is the same thing as x minus 3. And then the other is x plus negative 4, which is the same as x minus 4. And again, it doesn't matter which order you put the two factors. You could put x minus 4 first and then x minus 3 second if you wanted to. On our next example, it has to multiply to the constant, which is negative 6. And it has to add or have a sum of 1. My middle term here is 1, so it needs to add to 1. And if you notice, this is the same. We're using the same factor sets that we did in 1 and 4. The numbers have to multiply to negative 6, so 1 is positive and 1 is negative. So let's go ahead and write our possible ones that would work. So we have 1 and negative 6, negative 1 and positive 6. Neither of those add to 1. So let's try 2 and negative 3, and negative 2 and positive 3. And the pair that worked is this one. And so I would plug those in for m and n. So this is going to be x plus negative 2, which is the same as x minus 2, and then x plus 3. Again, it doesn't matter what order you put the factors in. I could have x plus 3 times x minus 2. Last one needs to multiply, have a product of negative 36. It needs to add, it has to have a sum of negative 5. And let's write our possible ones. Since it's multiplying to a negative, we know that one of them has to be negative, one of them has to be positive. And I can write these down. So I have 1 and negative 36, negative 1, positive 36. That pair didn't work. I have 2 and negative 18, and I have negative 2 and positive 18. That pair didn't work. I have 3, negative 6, and negative 3, and positive 6. Okay, that pair didn't work. 4 and negative 9. Oh, there's my pair that worked. I could continue finding the rest of my pairs, but once you find the one that works, you can stop. And you might be able to find those pairs without writing all the factor sets down if you know your multiplication tables pretty well. So this is going to factor into x plus 4. That's m and n. It doesn't matter which one's m, which one's n. And then x minus 9. And again, you could switch the order that you write those in. You could put x minus 9 first and x plus 4 second. This completes our notes.